There is an important interactivity in this book, which gives us the ability to check the solution after each exercise we solve. On page 85, we can see the interactivity. It has the video symbol. When we press on it, we observe an equation of a certain graph and an equation of a straight line. In the first example, we had the above equation, which is y equals x squared, and we want to get rid of x minus 1. These cursors are to increase or decrease the coefficients, and also we observe that the graph is changing. Here, the coefficient of x is not found, so we want to decrease the value to 0, and then the x component disappears. Since we only want y equals x squared, we also decrease the constant, which is plus 1, so that it will disappear. This is the graph of the equation y equals x squared. On the other hand, the straight line equation, which is y equals x plus 1, will be changed to plus 3. Thus, we will increase the constant from 1 to 3. Here we have the quadratic graph. We have enabled it to see the line. Also, this is the linear graph. We want to show the line, and it will be like this. When we get the intersection between the graph y equals x squared and the straight line y equals x plus 3, this graph looks like the graph we sketched. We observe that we get exactly the points of intersection between the two graphs. We note that the first point of intersection is minus 1.3, which is the approximate solution that we have deduced. Also, 2.3 was the second solution. Please note that it is very important to check your solution after each exercise that you solve. You have to simulate that y equals x squared and to draw the straight line, then enable the linear graph and to check the intersection points. We have interesting features within this interactivity, which is to increase the scale of the x and y axis in order to make it clearer. To conclude, through this interactivity, you will be able to check your answers. You will insert the quadratic function and insert the straight line equation. Then you must enable them in order to see the lines on the graph. Finally, you can deduce the intersection points, which are the solution of the quadratic equation.